Well, for this video, we'll learn about another agentometric titration, which is the Fajans Method. This uses an adsorption indicator. But before we go into the method itself, let's first discuss what is adsorption. Adsorption is the ability of solid substances to attract to their surfaces molecules of different substances. In other words, molecules adsorbs to the surface or sticks like an adhesive to the surface of a solid. Adsorption is favored by a high surface area, which means that your solid particles must be small in size. Going back to the Fajans method, your silver ions react with your halide to form your silver halide precipitate. Before the equivalence point, there is an excess of your halide ions in your solution. Thus, your negatively charged halide ions adsorbs to the surface of your precipitate. Since your indicator is negatively charged, it veers away from your precipitates. After the equivalence point, you now have a small excess of silver ions in your solution, which is your titrant, which displaces your halide ions in the adsorption layer. Due to your now positively charged adsorption layer, your negatively charged indicator ions can also adsorb to the positively charged environment. And this results in a sharp change in color. The indicator we use for this type of titration are weakly acidic dyes. Since our indicator reacts to the precipitate surface, we want a high surface area, which means our particle size must be small enough. For silver chloride precipitate, the most common indicator is dichlorofluorescein. This dye is greenish yellow in solution but turns pink when adsorbed to your precipitate. Some notes for this method. First is that the pH of the reaction must be controlled. As mentioned earlier, your indicator is weakly acidic, so it hydrolyzes to form its anion component and hydronium ion. There are some cases that your indicator anion displaces your anion of interest in your precipitate, which is another reason why your pH of your reaction must be controlled. The dye eosine is more commonly used for the titration for bromide, iodide, and thiocyanate because it has a sharper endpoint and is more sensitive, which means it can titrate less amounts of your halide or anions. However, this cannot be used for your chloride ions because eosine is more strongly bound to chloride ions, which means it could also adsorb to your crystallites even if not all your chloride has been consumed. Another note is that strong light, like daylight, should also be avoided because indicators are light sensitive and your silver salts could also decompose through light. That's it for this video. Thank you for watching. Bye!